All right, so we're on 8.5 today, which is about annuities. So basically an annuity is where you make multiple deposits into an account and interest is accruing during that time. So this is a form of compound interest, but it is a different formula because so last time in 8.4, we just did the basic compound interest, which is where you start out with a certain amount of money and then you, the money just builds interest over time. And then this is different because this is, you're depositing this a certain amount of money multiple times, like for example, every month. All right. It's important when preparing for your test that you know which formula to use. The regular compound interest formula, that's one deposit or one borrowing of an amount of money, and then the interest adds up over time, whereas annuity is depositing money multiple times, okay? So make sure you can understand the difference between those two formulas. All right. And other than that, pretty much all of the variables are the same, but just instead of having P, which is a principal amount, you have PMT, which just represents a payment or a periodic deposit. All right, so number one says, find the value of the annuity. So you have a periodic deposit of $200 at the end of each month. Rate is 4.9% compounded monthly, and the time is 15 years. Okay, so 200, that's your payment or your PMT. And then we have R would be 0.049 and T is 15. And then N, because it's monthly, N would be equal to 12. And then we're just going to plug all of that into our formula. So A equals 200. So in the formula, this formula is on the formula sheet. Like right here, it shows brackets, but that's just the same thing as parentheses. So this is just going to be double parentheses right here. 1 plus 0.049 over 12. Close the parentheses, and it's raised to the power of, and then we want to put parentheses 12 times 15. No. All right, and then close the parentheses. Minus 1. Close the parentheses again. All over, open parentheses, 0.049 over 12. All right, so this is how it's going to look when I type it into my scientific calculator. So hopefully you have your scientific calculator with you. And you can type that in, see what you get. So when you're doing this on your test, I highly recommend writing it down just like what I've done there. That would be considered showing your work. All right. Okay. So we're going to have 200, two open parentheses. And then I'm doing this from memory, so correct me if I'm wrong here. So this would be 1 plus, right? Is that right? 0.049 over 12, close the parentheses, to the power of, open parentheses, 12 times 15, close the parentheses, and then minus 1, right? Close the parentheses, divided by, open parentheses, 0.049 over 12. All right, does that look good? I don't know. I may have been doing this for a few years. All right. So it gives me 5,000 or $53,013.71. Okay. And it says round to the nearest dollar, so we would round that to $53,014. So what we're saying here is if you have an account that earns 4.9% interest compounded monthly, and then you deposit $200 into that account at the end of every month for 15 years, at the end of those 15 years, you would have $53,014 in that account. Okay. So any questions about that? All right. So part B says find the amount of interest earned. So how might we go about answering that question? So there we have that money in the account. Now some of that money is in there because that's what you deposited, and the rest of the money that's in there is there because that's interest that you earned. So we want to figure out how much you actually deposited and then subtract that from the total, and the rest of that would be interest. So the total amount that you actually deposited into the account, you deposited $200 every month. So let's multiply that times 12. for 15 years. So let's multiply that times 15. And that would be the total amount that you actually deposited. So that would be 36,000. So you actually deposited $36,000 into the account, but you have 53,000 in there. So why is it 53,000? Well, because you earned interest. So your amount of interest is equal to the total amount, 53,014, minus the total amount of your deposits, which is 36,000. So $17,014 is the interest. All right, so any questions about that? So again, a mistake that people make here is using the simple interest formula. So like I said, unless it specifically says the word simple interest, you would not use the simple interest formula. So the simple interest formula has nothing to do with this. So regardless of what type of interest it is, you can always take like the final amount minus the amount you put in, and that equals the interest. All right, so number 2, same thing. Find the value of the annuity. So $12.50 is the payment, so that's the PMT. And then R would equal 0.0575. T is 27, and it's compounded annually, which means that N is equal to 1. All right, and just like I mentioned last time, if you look on if you're doing your homework and you have a problem where N equals 1, if you look at the example or something, it might show you a version of the formula that basically doesn't have N in it because they've already like plugged in 1 for N. So it's not a different formula. It's really just the same formula without N because we know N is 1. Okay. So A equals 1250 double open parentheses 1 plus 0.0575 over 1. Let's see, close the parentheses, raise it to the power of parentheses 1 times 27. And so, yeah, if you want to skip writing divided by 1 and multiplied by 1, that's completely fine. But I'm just going to be consistent here. Okay, after the 27 there, we're going to close the parentheses, and then we've got the minus 1, close the parentheses, divided by, open parentheses, 0.0575 over 1. All right, so then I'm just going to type that into my calculator. Oops, that sucks.
Okay, so that was 1250. Oh, double open parentheses, 1 plus 0.0575 over 1, close the parentheses, to the power of, open parentheses, what was it? 1 times 27, close the parentheses, divided by, oh wait, let's see, I need -1 right there, and then close the parentheses, divided by, open parentheses, 0.0575 over 1, close, enter. $76,619 because we're rounding to the nearest dollar. Is that what y'all got? Okay, great. Okay. All right. So then the amount deposited so that's 33,750. So the amount of interest equals 76,619 minus 33,750. So that's $42,869 is the interest. Okay. All right, so number 3 says find the amount of the deposits. All right, so this is saying you have a goal to get to $250,000 and you want to complete that goal in 19 years. So if your account has 6% interest compounded quarterly, then how much would you have to deposit every quarter in order to reach that goal? So it's basically the same formula, but you're just solving for a different variable. You're basically solving for the payment variable. And I believe that this form of the formula is on the formula sheet. So it's basically the same thing, except for it's just solved for the payment variable. So it's like it's like the same formula, but it has the A and the PMT swapped, and then it's flipped over. So it's kind of like you just multiplied by the reciprocal of that fraction to solve for payment. And I believe that form of the formula is on the formula sheet. So if you have your formula sheet, you can look at that. So it should be like that. So your goal is the A variable. So 250,000 is A. And of course, T is 19. and then R would equal 0.06. And since it's compounded quarterly, your N equals 4. Minus 1. To the power of NT. All right. So payment equals 250,000 times R over N. So 0.06 over 4, close parentheses, divided by, okay, so we need a double parentheses here around the denominator, just like before. 1 plus 0.06 over 4. Close the parentheses, to the power of parentheses 4 times 19, close the parentheses, minus 1, close the parentheses. So here's our formula sheet, the same one I gave you before. So I was just gonna look at it. Let's see. So it's basically the only thing that you have to, that's not on here that you need to remember is when you're doing the exponent that you want to put parentheses around the exponent. So everything else, all the parentheses are given, but except for that one, you just need to remember to put parentheses around your exponent. All right. All right, let's see.
Okay, so we've got 250,000 parentheses 0.06 over 4, close the parentheses, divided by 2 open parentheses, 1 plus 0.06 over 4, close the parentheses, to the power of, open parentheses, 4 times 19, close the parentheses, minus 1, close. So 1785, if we round it to the nearest dollar, 1785. Is everybody getting your calculator? Everybody know how to use your calculator? Is it working for you? All right. If you don't have one, you really, really better have one pretty soon. Let's see. Now, actually, technically, we should round this up to the next dollar, because if we round it, if we want to get to our financial goal of 250,000, if we do 1785, that doesn't quite get us there. So we really should round this up to the higher dollar amount, even though it's 36 cents or whatever. We can round down, but if we round down, we won't actually reach the goal. So we should really round it up to be 1786. I think so. And I think it specifically tells you on the homework to round it up to the next dollar or something like that. Okay, so then let's see. So you're going to deposit 1786 quarterly, so 4 times a year for 19 years. So 1786 times 4 times 19. So that's 135,736. Okay. So that's how much you deposited. So the amount of the interest would equal 250,000 minus that. So $114,264 of interest. So the amount of interest earned is almost equal to the amount of deposits. Okay, any questions about that? Okay, so number 4, same thing. So we're trying to reach our financial goal of $1.5 million. And we wanted to complete that goal within 20 years. So 1,500,000 is A, T is 20 years, and our account earns 9.5%. So R equals 0.095. That is compounded semi-annually, which means 2 times a year. So N is 2. So we need to figure out our
payment that we make to achieve that. So PMT equals, so 1,500,000 times R over N, so 0.095 over 2, close the parentheses, divided by double open parentheses, 1 plus R over N again, so that's 0.095 over 2, close the parentheses, to the power of 2 times 20 minus 1. All right, I think I don't need to show this on the calculator this time. I think y'all get it. So let's round it up to the next dollar. So that would be $13,196. So we're going to deposit $13,196 2 times a year for 20 years. So the total amount we're depositing is $527,840. So the amount of interest earned equals the 1,500,000 minus the amount of the deposits, which is 527,840. So I can see here that basically you've almost tripled your money. You deposited 500,000 and you ended up with 1.5 million. So you almost tripled your money in this situation. So the interest is almost going to be double of the deposits. And that's why Einstein says this is the 8th wonder of the world. So the amount of the interest is $972 or $972,160. Okay, so that is the end of that section. So I believe our exam, so next time on Thursday, we are going to complete chapter 8. So 8.6, 8.7, and 8.8 are all lumped into one section and they're all lumped into one homework. It's because they're all really small. It's not a really long lesson. And then a week after that, we'll have our exam. I went ahead and already got the test reviews for you to start working on. Oh, sorry. Yeah, I was kind of waiting for everybody to take the last test before I grade it, which they did yesterday, and I did start grading it. So hopefully I'll have that graded by Thursday.
All right. Make sure you continue to do your homework. Any questions about anything? I'll see y'all Thursday. You should be able to. You just